Hello again, algebra students. I hope that you feel comfortable with what we did yesterday. We were talking about the elimination method, and I only called it the addition method as another name for it. However, if you remember, I said during the lesson that we would make sure yesterday that every problem that you had, every system of equations, one of the variables would have opposite coefficients to start the problem. Today, that's not going to happen on all the problems. We're going to have to learn to do another step. We're going to have to use some multiplication to be able to get those opposite coefficients. And then we'll use addition or subtraction. I'll even tell you right now, I don't ever do these with subtraction. There's a way to do that, but I am going to stick with addition on all of these problems. I'm just mentioning that that is an option that you can use. This is the kind of problem that we could possibly use subtraction with, but again, I'm not going to do it that way because I see students committing mistakes that way. In this problem, I don't have any of my variables that have opposite coefficients. Now, I know that the top y has a positive 4y, the bottom has a negative 6y. Just because one's positive and one's negative, again, that does not mean that they are opposites. They're not the same numbers. If it was positive 4 and negative 4, that's what we want. We have everything all lined up, so the x's are lined up, the y's are lined up, the equal signs are even lined up, and they both happen to be equal to 11. However, what I don't have right now in front of the x's, both of those are really just a positive 1x, and this is a positive 1x. If I want to be able to have opposite coefficients, this is where a multiplication step is going to come in. I want to turn one of those positive 1x's into a negative 1x. So if I would multiply this second equation by negative 1, distribute it to everything, including after the equal sign. We've never done that before, I know, but it's not a big stretch because we know how to do distribution. The entire equation is going to get multiplied by negative 1. So I'm going to just rewrite what I've got now. The first equation didn't change. That'll be a 1x plus 4y equals 11. When I distribute this, that'll be a negative 1x. Negative 1 times negative 6 is really a positive 6y. And then don't forget this. This is the most common mistake that I see is people forget to distribute after the equal sign. That's going to be a negative 11. Now, this is exactly like yesterday's lesson. Add the two equations together. The x's are opposites. They'll go away. 4y plus 6y is 10y. 11 plus a negative 11 is 0. Well, we can solve this. The y is equal to 0 because 0 divided by anything is just 0. Now I need to find the x. I have to go back into one of the equations. I'm going to use the top equation. Let me just rewrite that down here. So instead of 1x, I'm just going to write x. The y was 0, remember. So 4 times 0, that's just 0. Oh, I didn't mean equals there. So I'll have x plus 0 equals 11. Well, adding 0 doesn't do anything. It means that the x is 11. So my ordered pair, x first and then y, would be 11 and 0. Now, if I would check that using the second equation, and I'm going to use the second equation because I just used the first equation. If I made a mistake in the first one, or the first time around, I wouldn't probably catch it the second time around because I'll do the same thing. But this x was 11. 6 times 0 is just 0, and 11 minus 0, yeah, that's 11. That works. So remember, you can always substitute in to check your answer. This problem is similar. You can see that I have 3x and 3x. They're exactly the same. So what I really need to do is get one of those x's to be a negative 3x. It doesn't matter which equation you multiply it. We're going to multiply by a negative 1, just like we did in the other problem. I'm going to choose this top equation this time. I'm going to multiply this one by negative 1. I'm choosing that one just because the other numbers are smaller, so when I make them into negative numbers by distributing this -1, I'll still end up with easier math to do. Now, I've got this spaced out enough that I could really rewrite this new equation right here. I think that that may be confusing for you because you probably, hopefully you are writing these down, but you probably have these on one line and then the next line down. So I'll just take that first equation and I'll write it underneath the second equation. So -1 times 3x is a -3x. -1 times 4 is a -4y. And -1 times 19 is a -19. Now my x's are opposites, they go away. 6y and -4y, that's 2y. 33 and -19, or 33 minus 19, that'll be 14. And then divide. So y is 7. Now that I know that, I have to go back into one of the two equations. Again, it really doesn't matter which one you pick. I'll pick the top one again, a little bit smaller numbers. So 3x plus 4 times 7 for the y equals 19. 4 times 7 is 28. And when I subtract the 28, think about it as adding a -28. That will be -9. So x is -3. The ordered pair, remember always x first, even though we didn't find it first. -3 and 7. This time, my y's are exactly the same again. They both happen to be -3y's this time. So I really need one of them to change into a positive 3y. And to get it to change signs, really all I need to do is just multiply by a -1. It doesn't matter which equation you multiply by a -1. I'm going to multiply the second equation by -1. Again, either equation would be just fine. When I do that, let me write this one, I guess, to the side. So the top equation doesn't change. 2x minus 3y equals 9. Second equation, when I distribute the -1, that'll be a positive 5x. -1 times a -3y will be a positive 3y. That's what I wanted. And -1 times 30 is going to be a -30. The y's are opposites. They cancel out. So 2x plus 5x is 7x. 9 plus a -30, or 9 minus 30 is going to be -21. So x is -3. Now that I know that x is -3, I'm going to pick one of the two equations. It doesn't matter which one. I'll probably pick the top one just because the numbers are a little bit smaller. 2 times, here's what the x was, minus 3y equals 9. Now, by the way, I picked that top equation. I could have picked the bottom equation the way it started or the way I changed it. So if you wanted to use this equation right here to substitute in so you'd have a positive 3y, you can absolutely do that. This is now a -6 minus 3y, or plus a -3y, equals 9. So we'll add 6. And then we'll divide by -3, which is going to give me that y is -5. And as always, please don't stop right there. Make sure that you're answering your question as an ordered pair. X and then y. I have a new issue on this one. I don't have everything all lined up. Just noticing where the equal signs are, they are not lined up. And I don't have, but x and y together on one side, for instance. We've been doing most of our problems like the top equation looks, with the x and the y together and it's equal to the constant, the regular number. So let's take the second equation and make it look like the first equation. Let's move the 3x to the other side of the equation. So if I would subtract this 3x, this equation turns into negative 3x minus 5y equals 25. Now, if I'm looking at this equation with this equation, at this point, it's really nice because my x's are opposites. So I'm just going to take that top equation and write it underneath here. So I've got 3x plus 2y equals negative 19, and my x's cancel out. Negative 5y and positive 2y is negative 3y. 25 minus 19 would be 6. So y is negative 2. Now that I know what the y is, I have to substitute back in to find the x. And you can use either of the original equations or you can use the rearranged equation. I don't know that there's really any advantage to any of them, so I'm just going to go up to the top equation. I'm going to say 3x plus 2 times the y was equal to -2. I'm so sorry that I keep hitting bells, but I can only record like during this middle time of the day. So you're going to hit bells, I'm sorry. So 3x plus a -4 equals negative 19. I would add the 4 to get rid of that. So I get that 3x equals negative 15. And x is negative 5. So my ordered pair, x and then y, would be negative 5, negative 2. Also, this is not lined up nicely. However, it's also not quite as nice as the last problem. So let's do the same first step. Let's get the x and the y both on the left side of the equal sign. So let's start by rearranging this equation. Let's move the 4x. So I have 4x minus 2y equals 18. Now I've got everything lined up. That's great. However, this is a negative 2y, and so is this. So I'm going to need one of my equations to turn into a positive 2y. Well, since I already made a change in that second equation, let's take this first equation and multiply it by a -1. That would change it into a positive 2y. When I distribute this, and if you remember, I said, that's the step that people forget. Let's just rewrite it so that it's underneath my 4x minus 2y equals 18. So -1 times 6x is a -6x. -1 times a -2y is positive 2y. And -1 times 32 is a -32. Y's are gone. That was my goal. 4x minus 6x, or plus a -6x, is a -2x. And 18 plus a -32, that is going to be a -14. And when we divide, I'll get that x is 7. Now that I know the x, I have to find the y. I don't care which equation you use. You can use one of the rearranged equations or one of the original equations. And I've been saying, I try to avoid those negatives. Actually, I'm going to use this equation because the y is almost by itself. Not entirely, but close. So I've got -2y equals -4 times the x was 7 plus 18. That's a -28 plus a positive 18 gives me a -10. So I get that y equals 5. So my ordered pair is going to be 7, 5. One last problem. This time I have an issue because I can't just multiply it by just a -1. If I look at my x's, I can't multiply by a whole number anyway and get those to be opposites. I could, what we're going to do in the next lesson, is look at this and try to get both of those to be 6x and a -6x. However, if I look at the y's, this is really a positive 1y, and here we've got a -4y. If I could make that top equation turn into a positive 4y, then I'd have opposites. So I would just have to decide, what do I need to multiply by to make this a positive 4y? I'm going to multiply that entire equation by 4. So when I distribute that, again, don't forget all the parts. I would have 8x plus 4y equals -4. And now my y's are eliminated. 3x plus 8x is 11x. And 15 minus 4 is 11. X is 1. Now that I know what the x is, I have to find the y. And again, the easiest place is going to be in this top equation because the y doesn't have a coefficient that shows up. It's just a 1. So I'll have 2 times, there's my x, plus y equals -1. So that's really 2 plus y equals -1. So I would have to subtract the 2. So I get that y equals -1 plus a -2 is a -3. So my ordered pair is 1, -3. Today's worksheet is systems with elimination. So you're going to have to multiply. In most problems, you have to multiply one of the equations by something so you can get opposites. Make sure you check your answers with Schoology, but if there's something that doesn't make sense there, let me know. We're here to help you. And then when you're all done checking it, make sure that you take the formative in Schoology. Let me know if you need help.